Hello and welcome to another video. In today's video, we're going to be looking at the third and last application of Barrow's theorem, which is to find the area between two functions that do intersect. So this would look something like this. Here we have our graph with our x-axis, our y-axis, and our 0. And we have one function that goes like this, for example, and another function that goes like this. And we see that this intersects in 2 points, this point and this point. Well, we want to find the area between points A and B, not under the curve, not above, inside these two functions. And to do this, we use Barrow's theorem by following a simple and quite straightforward formula, which is the formula of integral of b and a. It is the same one as the previous one, f of x minus g of x dx, for all that b is greater than a, that there are points of intersect, points pi's, between f of x and g of x, and that both a and b are points of intersect. A, b allow points of intersect. And also that not including, but between a and b, that f of x is greater than g of x. So let's practice with a simple example. Our example is f of x equal to x squared and g of x equal to x plus 1. Well, our first step is that we need to find the points of intersection. To do this, we equal both functions. X squared is equal to x plus 1. Therefore, x squared minus x minus 1 is equal to 0. Now, we solve factorization. We have seen this in another video. If you don't remember, go check out my videos on factorization. But this is simply going to be x minus 1 times x plus 1 equal to 0. So we can say that x minus 1 is equal to 0 and x plus 1 is equal to 0. So this implies that x is equal to 1 and x is equal to minus 1. So there we have it. This is going to be our a, and this is going to be our b, as obviously our b has to be bigger than our a. Now we need to find which function is greater between these 2 points. So let's get point 0. Let's evaluate it here. 0 squared is 0, and g of x 0 plus 1 is 1. So in this case, our g of x is bigger. So we're going to have to write first, between 1 and minus 1, x plus 1 minus x squared dx. This is going to be equal to, this is going to be equal to minus x squared plus x plus 1 dx, and this is pretty much minus x to the power 3 over 3 plus x squared over 2 plus x evaluated in the points 1 and minus 1. So we have here that minus 1 to the power 3 over 3 plus 1 to the power 2 over 2 plus 1 minus 1 to the power 3 over 3 plus minus 1 to the power 2 over 2 minus 1. And this is going to be minus 1 to the power 3 plus 1 to the power 1 divided by 2 plus 1 minus 1 to the power 3 minus 1 to the power 3 is minus 1, so minus 1 plus 1 over 3 plus minus 1 squared is 1, so plus 1 over 2 minus 1, which we're going to have minus 1/3 minus 1/3 minus 2/3 plus 1/2 minus 1/2, so we cancel these two out, and plus 1 minus 1, so plus 1 plus 1 plus 2. So we have minus 2/3 plus, we convert this into a denominator of 3. 2 times 3 is 6. 6/3. So this is going to be equal to 4/3. And this is in units squared, because this is the area between the functions x plus 1 and x squared in their intersections between -1 and 1. Thank you for watching. That will be all for today's video. Check out my next video, in which I will be continuing to solve exercises of Barrow's theorem regarding the area between two functions that do intersect.